Hello friends, this is Guruji Online. Today we are going to do some problems pertaining to capacitance. This is a sub-chapter in electricity and this is very important chapter, and if you understand it fully, then this is very easy also. As you are seeing, I have given some formula on the right side. These formulas you all already know, and based on these formulas we are going to do some questions. So question number 1 is, what is the capacitance of a drop made by two spherical charged balls of identical radius of 2 mm each? So in this case you have two drops and they are merged to form a single drop. These two drops are there. They are merged to form a single drop, and every drop is having a radius of 2 mm. So basically it is a capacitor, spherical capacitor problem, and it's a isolated one. So we know capacitance in case of isolated sphericals, this formula is there: 4 pi epsilon 0 into R. Now, by conservation of volume, we will try to find out this R. Basically two drops are there, they are merging to form one drop. So suppose its radius is R dash. So what will be the volume of this? A spherical drop, that will be 4 by 3 pi R dash cube, and this must be equal to 2 times 4 by 3 pi R cube, where R is the 2 times because 2 drops are there. So with this we can find out R dash will be equal to 2 raised to 1 by 3 into R. So what is the capacitance? 4 pi epsilon 0 R dash is nothing but 4 pi epsilon 0. R dash is nothing but 2 1 by 3 into R. Now we put the values as 4 into pi, you know, into 2 raised to 1 by 3, you can find out. What about epsilon 0? Epsilon 0 is nothing but 8.85 into 10 raised to minus 12 F upon meter, that is farad upon meter, into what is R? R is nothing but 2 mm, that is 2 into 10 raised to minus 3 meter. So this will come out as 2.8 10 into 10 raised to minus 13 farad. So it was a very simple problem. Now we will go to the next problem. Next problem is like this. In this figure, it says that volume is 10 volt. That is, volume is 10 volt and every capacitor is 10 microfarad. So every capacitor, that is 10, that is 10, that is 10, that is 10. Now what we have to find out? We have to find out charge on capacitor A and B. That is, we have to find out QA and QB. In this case, this is the battery which is having 10 volt of voltage. So naturally, these 2 points will have, these are equipotential points. They will, here in this capacitor, the V will be VA. Capacitor A, VA will be nothing but 10 volt, and C A is given as 10 microfarad. That means QA will be nothing but 10 into 10 microcoulomb. That is, now this was simple, but now we have to find out what is QB. For finding QB, in this circuit also, the voltage is 10 volt. If we find out what is the potential between these two, then our problem will be easy. Now, what is the equivalent capacitance of this? These two capacitance are in series, and this capacitance is in parallel to this. So, equivalent C equivalent of this will be nothing but 10 plus 10 into 10 divided by 10 plus 10. Capacitor in series, capacitor in parallel. How we are going to find out the equivalent, that you already know. So now this gives us 15 microfarad. Now here, if we draw simply, this is 15 microfarad and this is 10 microfarad, and in the voltage in between is 10 volt. So what will the voltage here? This you can find out. Here charge will be same, so Q will be equal to C1, or if we denote 1, then this is 2, to C1 V1 is equal to C2 V2. This is nothing but 15 into V1 we have to find out is equal to C2 is nothing but 10, and V2 we can write as 10 minus V1. So from here, this is 25 V1 is equal to 100, or V1 is nothing but 4 volt. Now this between these 2 points, that means between these 2 points this is 4 volt. Now these 2 capacitors are equal. So naturally in capacitor B, VB will be nothing but 4 divided by 2, that is 2 volt. So QB is nothing but, what is the capacitance? That is 10 microfarad into 2 volt, or 20 microcoulomb. So I hope you understood this problem. There was nothing much problem in there. It was very easy. Now we will go to next question quickly. In this question, we have this circuit where V is given as 12 volt. Capacitance of A is 4 microfarad, B is 6, and this is 3. Now it says, firstly, this key is closed. When this key is closed, firstly this key is closed after charging full. After full charging of A, now this switch is opened here and it closed here. So what it is saying is, what it is asking is final charges on capacitor A, B, C. So first of all, we will see what is the initial QA, charge on the capacitor A. When this key is closed, the left hand side, then this circuit is complete, and due to this capacitor will be charged. And how much it will be charged? QA is nothing but C into V, or you can say 4 into 12, that is 48 microcoulomb. Now, when this switch is turned right away, then the connection from the battery is disconnected. Now this charge QA, it will discharge, and capacitor B and C, they both will be charged up till such, and this process will go on till such time when the equilibrium is achieved. Now, when will be the equilibrium achieved? When these 2 points will have equal potential. When they will be when there will be potential will be equal, then charge distribution will stop. So we have to find what is the equilibrium position, and equilibrium position, what will be the, first of all, what will be the voltage. Charge is basically this initial charge. So for finding out what will be the voltage, let us find out what is the C equivalent of this circuit. C equivalent is nothing but, this is 4 plus, this is in series, it means 6 into 3 divided by 6 plus 3. This will become 6 micro. Now this is the C equivalent and this is the charge, then equilibrium voltage will be nothing but 48 divided by 6, that is 8 volt. Now we know, now this is having 8 volt and this is having 8 volt together, but these two will have separate voltage. Here Q will be same but separate voltage. Now what will be the charge when the potential is 8 volt? What will be the charge here? Final Q A is nothing but C into V, means C is nothing but 4 into V is 8, means this is 32 coulomb. Got it? Now, what was the initial charge? 48. Out of this, now it is remaining is only 32. So what is the charge? Now the charge at B and charge at C will be equal. QB, because they are in series, will be nothing but 48 minus, this is the only charge remaining. So I think this is simple. You understood the problem. Okay, now let's go to the next problem. This problem says is a parallel plate capacitor with capacitance as 12 picofarad. Is charged by battery with voltage 12 volt. After charging, battery is disconnected. Now a dielectric slab with dielectric constant 5 is slide in between the plates. Now we have to find out what is the potential energy before and after the slab is slid in. So in this case we have a basically parallel plate capacitor. It is charged 12 volt battery. So what is the potential energy? Potential energy is nothing but half CV square or Q square upon 2C. This is so we can write this as 1 by 2 into C is your 12 into 12 into 12. This is basically picofarad. So we can write as minus 12, or we can write as or forget about, we will write the result in pico only. So this comes as a was 864 pico joule. Now you are going to slide a dielectric slab whose constant is dielectric constant is 5. Actually, due to this, C K will become K into C. C is the original C. That is when there is a air. Now, this is the initial potential energy. Final potential energy, what will be? It will be nothing but Q square upon 2. If we write this K C, and this is nothing but Q square upon 2C into 1 by K, and this is nothing but 864 picojoule into 1 by 5, or this is nothing but 172.8 picojoule. Now you see this. This is the potential energy after you slide the dielectric slab. potential energy is basically it has reduced. By how much? 864 minus 172.8 picojoule, or it is nothing but 691.2 picojoule. Where this energy has gone? So basically, this energy, this system is doing on the slab, because if you bring the slab near to the plate, it will suck the plate by expending this much amount of energy. Now, suppose this is, your plates are frictionless. Then what will happen? This slab, it will be sucked here, and this potential energy will be converted into kinetic energy, like this. And after that, when it starts coming out, then again there will be backward force and the system will try to suck again in the upward direction. So in fact, this slab will oscillate. It will have a oscillatory motion in the between the slabs, between the plates, provided it does not have any friction or this energy is not expended anywhere else. So I hope this you must have understood these problems, and if you like this video, please do like it and subscribe this channel. We are going to bring some more problems pertaining to capacitance in my next video. Thank you very much.